All right, let's talk about something that sounds, well, completely impossible. A way to solve algebra problems with absolutely zero mistakes. Yeah, you heard me. Zero. This is a total game changer, and today we're going to break down exactly how it works.
So, let's just get right to it. Is it really possible? Can you tackle a tough algebra problem and not make one single tiny mistake? I mean, come on. That's the huge question here, right? And honestly, the answer might completely flip how you see math from now on.
Okay, first things first. We gotta understand the real enemy here. And let me tell you, it's not what you think. The enemy isn't that algebra is too hard. No, the real problem is something way sneakier. It's what I call the algebra trap. Just let this sink in for a second. Algebra isn't hard, it's fragile. I mean, think about it. The ideas themselves, usually pretty straightforward, right? But the process, man, it's like glass. One tiny little crack, one wrong move, and the whole thing just shatters.
You know exactly what I'm talking about. We've all been there. You're deep into a problem, maybe 20 minutes in, you're feeling good, and then you check the answer, and it's wrong. And why? It's never because you didn't get the big idea. Nope, it's because you dropped a tiny negative sign way back on line 2. That one little slip-up is where all the frustration comes from.
So here's the most important part. Listen up. If you're struggling with this stuff, it is not because you're bad at math. It's because nobody ever gave you a process, a system that's actually designed to handle how fragile it is. You've been taught what to do, but not how to do it perfectly, every single time.
But what if there was a way to just replace that broken process with a real system? A system built from the ground up to kill mistakes before they can even happen. Well, that's exactly what we're about to get into. And this is the secret sauce right here. It's a total reframe of your goal. You're not just trying to find the answer anymore. No, you're running a system where the right answer is the only possible outcome. It's a huge shift from just hoping you get it right to building a process where you literally can't get it wrong.
Okay, so how does this actually work? Well, the whole system is built on just 3 simple but super powerful pillars. Think of them as the secret ingredients. Let's break them down. And here they are. Pillar number 1 is control. This is all about meticulous, almost obsessive variable tracking. You need to know where every single piece of that equation is at all times. Number 2 is simplify. The rule is simple. Simplify early and simplify often. Make the problem smaller and easier at every single step. And finally, number 3, verify. This isn't just checking your work at the end. It's a constant verification process built right in.
All right, talk is cheap, right? Theory is one thing, but let's see how this system actually works under pressure. We're going to take a classic algebra problem and solve it flawlessly using these 3 pillars. Let's do it. So here's our opponent, a classic quadratic equation. Now, you know these things are minefields for mistakes, right? People forget negative signs, they mix up their factors. It's the perfect test for our system. So, where do we start?
We kick things off with pillar 1, control. We need to factor this thing. So what are we looking for? We need 2 numbers that multiply to give us -5 and add up to +4. Let's think. Okay, got it. It's got to be +5 and -1. So we rewrite the whole thing. Now we have x plus 5, x minus 1 equals 0. See that? Just by doing that, we've taken control. We've locked down the structure of the problem.
Now for pillar 2, simplify. We bring in the zero product property. You remember this, right? If 2 things multiply to make 0, then one of them has to be 0. And this is awesome because it lets us split one complicated problem into 2 super simple ones. Either x plus 5 equals 0 or x minus 1 equals 0. It's a perfect example of how simplifying just demolishes the chance for you to make a mistake. And boom! Just like that, we've got our 2 potential answers. X is either -5 or x is +1. See? No crazy calculations, basically no room for error. But hang on! Are we done? No way! Not even close! And now for the final, and I mean non-negotiable step, pillar 3, verify. We have to prove our answers are right. So let's take that first one, x equals -5. We plug it back into the original equation. We get -5 squared plus 4 times -5 minus 5. That's 25 minus 20 minus 5, which is 0. Perfect. Check. Now for the other one, x equals 1. We get 1 squared plus 4 times 1 minus 5. That's 1 plus 4 minus 5, which is also 0. Perfect. We haven't just checked our work. We have proven that our solutions are correct. This is part of the job, not just something you do at the end.
And there you have it. By sticking to the system,
Control, simplify, verify. We didn't just stumble upon the right answer. We built a road that literally made it impossible to make a mistake. A zero-error result achieved.
So what does this actually mean for you, watching this right now? It means a complete transformation. We're not just talking about algebra anymore. This is about how you tackle any complex problem. It's about moving away from that chaos and guesswork and into a state of calm, methodical confidence.
I mean, just look at the difference here. This is the shift. You go from that awful feeling of, I hope this is right, to the absolute certainty of, I know this is right because I trusted the process. It completely swaps out frustration for pure confidence.
And really, that's the ultimate lesson here. Mastery in anything isn't about being some kind of genius. It's about having a process that is so solid, so reliable, that it guarantees a great result every single time. You control the process, and the result, it just takes care of itself.
So, let's wrap this up with your takeaway checklist. From now on, before you say a problem is done, you gotta ask yourself 3 questions. 1, did I control my variables like a hawk? 2, did I simplify every single chance I got? And 3, did I actually prove my solution by verifying it? If you can say yes to all 3, my friend, you are on the path to 0 errors. So that's it. You now have the system. The tools are in your hands. So the only question I have for you is, what's it going to be? What's that one problem, that one equation that's been driving you crazy that you're going to go and absolutely conquer first?